Okay, we're doing Sullivan's Precalculus, and we're at the end of section 1.1 doing the exercises. And here I've screenshotted from my PDF version of the textbook questions 29 through 34, and they're all basically asking the same thing with different given different points. So it says plot each point and form the triangle ABC. Verify that the triangle is a right triangle and find its area. Okay. So this won't be too hard. Let's start with 29. A is negative 2 and 5. So here's negative 2, 1, 2, 3, 4, 5. Here's A. B is 1, 3. Here's B. And C is negative 1, 0. So the triangle looks like this. Oh, that was really bad. If you tilt your head kinda to the left, you can see that this does indeed look like a right triangle. What the heck. And this would be our right angle right here. So I'm just going to assume this is a right triangle. I'm not going to actually prove that it is. So we need to find the height and the base. The length of the height and the length of the base. Why? Because the area of a triangle is 1/2 base times height, right? So we have the 1/2. Now we need to know the base and we need to know the height, because if you turn your head it looks like that, with this being B and this being H. So how do we find base and height? Well, we use the distance formula from C to B. So let's first find from C to B the height of the distance of the base. So B, we'll say B is x and y 2. You can barely see that. We'll say B is x and y 2, and we'll say C is x and y 1. So we should have x2 minus x1, which is x2 is 1, minus x1, which is negative 1, squared, plus y2, which is 3, minus y1, which is 0, squared. Okay, and that simplifies to, this is plus a positive when you have minus and negative, so 1 plus 1 is 2, 2 squared is 4, plus 3 minus 0 squared, which is 3 squared, which is 9. So this turns out to be way too small, big. This turns out to be 4 plus 9 is 13, square root 13. Okay, so B, we'll say, is square root 13. 18 equals. Now we need to find H, the distance between B and A. So we're going to use the distance formula again. Okay. Square root, we'll say B is still 2 and A will be 1. So x2, which is 1, minus x1, which is negative 2, squared, plus y2, which is 3, minus y1 is 5 squared. And we get square root 1 plus 2 is 3, squared is 9, plus 3 minus 5 is negative 2, squared is 4. Okay, so square root of 13 again. Alright. And find its area. So our area is 13 squared times 13 squared. That's 13 times 1/2. So our total area now for this particular triangle is 1/2 times 13, or 13 over 2. Alright. we did 29. So now let's do one more, because I think you have an idea of how to do these. And this video, I don't want to be too long. Alright, so let's do, what's a good one? Something that can fit on this coordinate plane. We'll do 34. Alright, so 34. I mean to write these so you know. So A is 4, -3. So this is A. B is 4 and 1. Oh, this is going to be easy. And C is 2 and 1. Oh, this is really easy. So we do know, in fact, actually, this is a right triangle, because we have a 90-degree angle right here. We know that. Okay, and now all we need to do is find the area, which is 1/2. Area of a triangle is 1/2 base times height. Okay, so this we could say is our base, this we could say is our height, but you could look at it any way, because if you turn this sideways on its side, or if you tilt your head left, you'll see that this could easily be the base and that could easily be the height. Doesn't matter. Pick one. So now we'll do the distance to find the length of the base and the length of the height. So we'll find B first. So distance between B and C. I shouldn't write subscripts for that. We'll say B is our x1, y1, and we'll say this is our x2, y2. Doesn't matter. So x2 minus x1, 2 minus 4. Oh, I picked the wrong one, but it's okay because math is awesome. And then 1 minus 1 squared. This turns out to be -2 squared plus 0 squared. And -2 squared is 4. 0 squared is 0, so square root of 4, which is 2. Oh, and we could have just counted this as well. 1, 2. So the distance here is 2, our base. Say that equals that. Okay, so this is easy, really easy actually, because I don't even need to do the distance formula now that I just realized this. If B is here on the y-axis, and if A is here, we just count 1, 2, 3, 4. So this is a distance of 4. Just now realized that. Wow, shame on me. So we'll plug this in. 1/2 times 2 times 4 is the same as, well, this cancels out, so all you're left with is 4 as your total area for this particular triangle. But that's funny because this just shows you, if you have a triangle, a right triangle that's like this, its hypotenuse is the only diagonal line, then it should be you shouldn't even have to use the distance formula, because you can just count increments like this and easily find the area by plugging it in. So I'm actually glad I picked this problem. I wasn't intending on this to happen, but I'm glad I did. So we'll do more questions in future videos.